All right, so we've got our 7-7 homework in front of us. Not doing ACT practice anymore. It's time to start getting ready for your EOC. So everything's EOC practice. Still got to show your work. Anyways, this is number 3. You're supposed to, well, I forgot the instruction set. I think it's write the correct sigma notation. Yes, write the correct sigma notation. All right, first off, I see 1, 2, 3, 4 terms. So even if I know nothing, I know that this is going to be the sum from, let's just say, n equals 1 to 4, because there's 1, 2, 3, 4 terms. See, 1, 2, 3, 4. And what goes in here has to be the pattern. So this might be kind of a tough one, but what I see is I see 2 to the first, 2 squared, 2 cubed, 2 to the fourth, 3 to the first, 3 squared, 3 cubed, 3 to the fourth. That's kind of what I'm seeing here. I'm seeing 2 to the first over 3 to the first, 2 squared over 3 squared. And by the way, there's pluses, whatever. Plus 2 cubed over 3 cubed. That's what I'm seeing. So when I talk about my pattern, that was a horrible looking signal, wasn't it? I'm talking about 2 to the n over 3 to the n. Because think what this creates. It creates 2 to the first over 3 to the first. You increment 2 squared over 3 squared. And there's the pattern for that one. All right, how many terms do I have here? 1, 2, 3, 4, 5, 6, 7, 8, 9, 10 terms. 10 terms. 2, 3, 4, 5, 6, 7, 8, 9, 10. 1 to 10. And again, here what I need is the pattern. Now, what I noticed here is I noticed that this was arithmetic. Adding 2. So I'm going to use the formula that a sub n is a1, a sub 1, plus n minus 1 times d. And the first term is 2. And the difference is 2. And aha, 2n. So there you go. They're not hard to do. You just have to, you know, have a good mind, I guess. All right, there's 5. Slide 2 of 9. And this instruction said you're actually supposed to find the sum. These are find the sum. Now, let's talk about this. And by the way, what does this mean? This is the 10th through the 16th terms. And I see 5K. All right, that's my goal. What is that guy? Now, here's the shortest way to do this. 5K looks kind of like y equals mx plus b. Since it looks like y equals mx plus b, useless. I know it's arithmetic. That's what I know. All right. I know it's arithmetic. So I get to use the form S of n as n over 2 times first plus last. Now n is going to be 16 minus 10, add 1 back. That's going to be 7. There's 7 terms. You can count with your fingers. And the first term here that I care about happens when I plug in a 10. So a sub 10 is simply 5 times 10, which is 50. And the last term here is a sub 16, which I plug in as 16. 5 times 16 is 80. I'll show you other ways of doing this one. This is just actually the quickest way if you know your formulas. I know it seems so hard for some of y'all. But anyways, I'm finding the sum of 7 things because n was 7. It must be 7 over 2. The first term was 50. The last term was 180. So the sum of 7 things here is going to be 7 halves. And inside is going to be what? 230? Not 180. Yeah. Typo. 80. 130. And, you know, I normally do this in my head, but whatever. I don't want to do that, and you all think I'm making things up. But it looks like my calculator doesn't want to work either. Try this again. Ah, there we go. Got 7 over 2 times 130. Oops. I did the multiplier key there. 455. Sum of 7 things is 455. All right, that's that from, oh, by the way, here's the long way. Plug in numbers. So the first term happens when I plug in a 10, that's 50. The next thing happens when I plug in an 11. The next thing happens when I plug in a 12. 5 times 12 is 60. The next thing that happens when I plug in a 13, 65. Notice it's incrementing by 5s. Then a 70, and then a 75, and then an 80. 10th, 11th, 12th, 13th, 14th, 15th, 16th. Well, that wasn't that long. All depends on how good with numbers you are. Some of y'all be pushing buttons. We have another evaluation here. And I don't think you want to write this out. I don't think you do. All right, so this little guy right here is a times r to the n minus 1. Happens to be tomorrow's lesson. It is the explicit form of a geometric sequence. All right. Notice how I'm lining things up here. All right, so with the first term being a 3 and the common ratio r being a 4. For a geometric sequence, the sum of n things is the first term, parentheses, since I'm typing this out, 1 minus r to the n divided by 1 minus r, close, close. So let's plug some things in and I'll write it out so it'll look more like the fraction needs to be. The first term is 3. The ratio is 4. I don't know if that parentheses is taller. The ratio is 4. And n here is 99 minus 1, add 1 back, which is 99 terms. So I'm going to raise this to the 99th power, and the bottom is 1 minus 4. And now what I'm going to do is I'm going to push buttons. That's all I'm going to do. What do we got here? We got 3 out front, parentheses. Let's go to math, num, n over d. You'll have your best luck here. Top is 1 minus 4 to the 99th power. The bottom is 1 minus 4. If you don't know that's negative 3, just type in 1 minus 4, arrow out, close your parentheses, be done with it. You get this teeny tiny decimal that I don't think your calculator can convert to a fraction. It can. That is 4.0173 Oh, it's huge actually, isn't it? Times 10 to the 59th power, which is a huge number. 4.0173. This is huge. It's huge. It's a gigantic number. It's huge. All right, the remaining stuff is all EOC practice. You'll notice they want on this question, they want us to find the remaining zeros if a known zero is x equals -6. And it says use synthetic division. Since you're told x is -6, don't change its sign. -6 times 2 is -12. 11 minus 12 is -1. -6 minus 1 is 6. -1. Why is this 6, 0? Remainder constant x squared. 2x squared minus x minus 1 is where the remaining two zeros are. So I said equals 0. And it says QF or factor. I feel like it factors. Probably does. I made this question up years and years ago. Let's see here. If I take away 2x and I add an x back, I'd be at -x. And I use that zero product property. X is -1/2 or x is 1. And by the way, there were 3 zeros. Billy Bob is about to eat lunch. He can choose from 2 primary dishes, 3 bread types, 8 different drinks, 3 types of vegetable, 2 types of fruit, and 4 desserts. Assuming he takes 1 item from each of the different categories, how many different possible lunches could he make? This is called a combination, and the total number of combinations is the product of the number of each choice to make. You can make a whole lot of lunches here, man. We have 2 primary dishes. There's 2 choices you can make. We have 3 bread types. There's 3 more choices. We have 8 drinks, 8 more choices, 3 vegetables, 2 fruits, 4 desserts. And I'll get some pretty big numbers here. Let's see, this is going to make 6, 8, 24. It's 48 times 24. No, I'm just too tired to do that. 1152. That's how many different lunches he could make. It's a lot of choices. All right, which of the following expressions are for x are solutions for x in equation 4 the x equals 12? Select all that apply. All right, so here's what I notice. I notice I have a base of 4. I have an exponent of x, which means I have an answer of 12. So I'm just going to do a straight up convert to log. Remember, log is bay. By the way, you are required to show work. So I have a log of base 4 whose argument is 12 and it equals x. So that means that this is a choice because it's solved for x, right? Solutions for x. Other things I can do here is I know change of base. I can do log of A over log of B. Or I can do ln of A over ln of B. Either one of them. If I do log A over log B, this becomes log 12 sitting over log 4, which is going to be that one. And if I understand the ln's, I'm going to be the ln of 12 over the ln of 4. which is going to be choice D. This thing had 3 correct answers. And I circled the wrong one. This happens. What did I write? I wrote log base 4. There we go. Oops. All right, 17. The following question has 2 parts. First, answer part A, then answer part B. Which of the following is the inverse of 1/2 to the x minus 6? You should know your 3 steps. Step 1, swap x and y. Step 2, resolve for y. 3 is notation. Some of y'all just can't do this. X is going to be 1/2 of y minus 6. We'll do the baby step. We'll add 6. What we'll do now is we'll multiply both sides by 2 to counteract the 1/2. And then 2x plus 12 must be equal to the correct notation, the inverse of f of x. And that's going to make this one choice D. All right, part B is easy to answer. The composition of a function, and this is your work, by the way. Composition of a function and its inverse is always x. Always. It's just the way it is. Moving forward, 18. For the polynomial function f of x equals x squared plus 5x plus 9x plus 45, select the values that correctly complete each statement. Now here's the reality of this. You are expected to remember how to factor by grouping. Now, total zeros comes from here. So the power function is x cubed, which means there are 3 zeros. At least one is real. And that's just a given. Now, we do have a total of 3 zeros. How many real zeros are there? Well, what we're going to do is we're going to factor. I know that both of the, I just look at the first 2 terms, I see an x to the second in both terms. It factors as x squared times x plus 5. If I look at the last 2 terms, I can pull a 9. And what I have here is I have x plus 5 times x squared plus 9. And since I want zeros, set equal to 0. Now by the ZPP, the zero product property, x plus 5 is 0, which means that x is negative 5, which is definitely real. And x to the second plus 9 equals 0, which tells me that x squared is equal to negative 9. And which means that x is plus or minus 3i, which is not real. So, ends up that I have 1 real zero, 2 non-real zeros. Oh, by the way, don't do something stupid like 3. 3 or 1 is a bad choice. Like, horrible choice. Part 3. Imaginary zeros happen in conjugate pairs. There will never be an odd number of non-real zeros. Always be even. Always. All right, more factoring. And what are the factors of this thing? And it got cut off too, didn't it? Let's see here. Somebody needs to fix their editing on this. Here's what we're going to do. I'll have to type back, but what we're going to do is we're just going to plug in numbers. Factors are created from zeros. So let's make out the list based on factors. Maybe x equals 4 is a 0. So it's x minus 4, so maybe x equals 4 is 0. I'm going to plug it in and see what I get. 4 cubed plus 5 times 4 squared. I don't think this is going to happen. Plus 2 times 4 minus 8 equals 0? I don't think so. There's no way that's 0. No way. That's going to be huge. All right, so I look at this one. Maybe x equals 2 is a 0. This one has some chance, but I don't think so. That would be a 2 that's cubed plus 5 times a 2 that is squared. And by the way, I already know this one isn't. Plus a 2 times a 2 minus an 8. Now, if I glance at this real quick, 2 cubed is 8. And this is definitely not a 0. All right, so moving on. Maybe x equals 1 is a 0. Now, half of you haven't figured out change signs yet, but I'm changing this sign. This one has a good chance. 1 cubed plus 5 times a 1 squared plus 2 times a negative 2 minus 8. This isn't a 0 either. That's 1 plus 5 minus 4 minus 8, which is negative 6. It's definitely false. All right, so what other choices do we have to make here? We can be negative 1, negative 2, negative 4. Negative 1, negative 2, negative 4. So I take it, I've already been negative 1. I can be negative 2. Kind of boring, isn't it? It's not necessarily hard. That's going to be negative 8 minus 8. This is going to be plus 20 minus 4 minus 8. And there is a 0. Yay! So I know that choice D, which was x plus 1, is, sorry, x plus 2. E, which was x plus 2, is a 0. So there's one of them. Let's see here. I forgot about D completely. D is when I plug in the negative 1. I don't think it's going to happen. Now look at this thing. That's negative 1 plus 5 minus 2 minus 8, not a 0. And the last one is negative 4. So I take a negative 4, I cube it. This is a select all. I figured there'd be another one. Doesn't look like there is, though. Maybe. This one might be it. What's this one yield? This one yields a negative 64 right there. Here it's got 16 times 5 plus 80 minus 8 minus 8. That is 0. So what choice was that? That was choice F. There's two of them. F, which was x plus 4. Those are your two answers. And as boring as it is, show the work of plugging in numbers. And it's boring. Reset the screen. 19 is a log. Sound intensity is measured in decibels on a logarithmic scale. The formula decibels is 10 log. P over P0 is used to determine the decibel level of a sound, where P is the intensity of a sound heard. P0 is the intensity of the softest sound a human ear can hear. Normal conversation is measured at 60 decibels. What is the ratio P over P0 for normal conversation? So this 60 dB goes right there. So 60 equals 10 logs of P over P0. Oh, I put that in the wrong spot. No, I didn't. It's 60 equals 10 log P over P0. I'm going to divide out the 10. 60 equals log of P over P0. Oh, and this isn't hard. This is just convert to logarithm. I thought it was written kind of funny. Every log has a base of, that's not mentioned, has a base of 10. So here's my base, my answer, my exponent, 10 to the 6th. Actually took me a minute to figure out what they were asking for. And that's what they want. They want that ratio. So there you go. Not hard at all. 10 to the 6th. And the last one of this video, and then I got to get my room together and make copies. Select all expressions that are equivalent to the 5th root of 32, a to the 4th, b to the 12th, c to the negative 5th. Here's a couple things I know. I know 2 to the 5th is equal to 32. That's what I know. So if it doesn't have a 2, I'm getting rid of it. Gone. Not picking those. Now it was pretty simple here. We divide the power by the root, and the remainder stays inside. So think about 32 as 2 to the 5th. 5 enters 5 one time. There's 2 outside. 5 does not enter 4. There's going to be a 5th root of 4 on the interior. I'm just going to write this out. Again, 5 does not enter 4. There's going to be a 5th root of a to the 4th on the interior. 5 enters 12 twice. B squared outside. B second inside, because the remainder is 2. 5 enters negative 5, negative 1 times. That's horrible. Let's reset this. 2 to the 5th, a to the 4th, b to the 12th, c to the negative 5th. 5th root. 5 enters 5 once, 2 outside. 5 enters 4 no times, a to the 4th inside. 5 enters 12 twice, remainder of 2, twice, remainder of 2. 5 enters negative 5, negative 1 times, c to the negative 1st out front. remainder of 0. Now, what do we have here? We have this one because of that negative exponent. And there's other ones here too. Let's think about making this thing look like, let's convert it to exponential notation. Let's think x to the p over r. This is 2 to the 5th over 5, a to the 4 over 5, b to the 12 over 5, power over root, and c to the negative 5 over 5. 5 over 5's cancel. A to the 4/5, b to the 12/5, and negative over negative c. So I'm also looking for that thing. Or maybe this one. That one works. That one works. There were 3 correct answers on that one. 3 of them. And that's it for that lesson.